to the Book Doctor channel. Here, we demystify mathematics and make it fun.
We have to write the following fourth-order differential equation as a system of first-order linear differential equations. Good. To begin with, we will introduce some new variables to represent y and its derivatives. So let's call x1 to represent y, x2 to represent y prime, x3 to represent y double prime, and x4 to represent y triple prime. Then we'll pick all these equations and differentiate them. So x1 is equal to y. When we differentiate x1, we'll have x1 prime is equal to y prime. On our chart here, the y prime is associated with x2. So we can say this is equal to s2. Then we'll pick the second equation, which is s2 is equal to y prime. Then when we differentiate this equation, our x2 prime will be equal to y double prime. And our chart, that is x3. Then we'll pick the x3 line. S3 is equal to y double prime. When we differentiate this equation, x3 prime will be equal to y triple prime. And from our chart, that is x4. Then we'll pick the last line, which is x4 is equal to y triple prime. When we differentiate both sides, our x4 prime will be equal to y to the fourth order. Good. Now we are come to write our system of equations. Remember, we are writing a system of first-order linear differential equations. So we want to pick the first line. We have s1 prime, which will be equal to x2. We want everything to be in x. So we'll avoid writing the y prime. We'll write s2. Then our s2 prime will be equal to x3. Then our x3 prime will be equal to x4. Then our x4 prime is equal to y to the fourth order. But we have to look for the expression representing y to the fourth order. So we'll make y to the fourth order from the original differential equation. So y to the fourth order is equal to minus 6y, then minus cos t y prime minus 5y double prime plus 2y triple prime, then plus the exponential function e exponent t. So since y to the fourth order is equal to this expression, we'll write s4 prime, which is equal to y to the fourth order. We'll write it using this expression. But remember, because we want to write it in our new variable, the y's and the y derivatives within this expression will be written in terms of x. So the first term here is minus 6y. And so writing the y, we'll write x1 because that is what is associated with over here. So to be minus 6x1. Then we'll have minus cos t x2 because s2 is associated with what? Y prime. Then minus 5 x3 representing the y double prime. Then plus 2 x4. Then plus the exponential function e exponent t. Good. Now we'll convert this one to a matrix. So the first will be a column matrix consisting of all the primes over here. That is our new variable primes. So the column matrix will be x1 prime, x2 prime, x3 prime, and then x4 prime. Then this is equal to, we'll convert these expressions on the right to a matrix. We'll write the matrix by picking the coefficient of x. Now look at the first line. We don't have an x1 component. We don't have an x3 component and an x4 component. We only have s2. So when we are picking the coefficient, we'll represent the first column here with 0, the second column here with 1, the next column will be 0, and the fourth column will be 0. So these are the column 1, 2, 3, 4. We are just picking the coefficient as such. So it is only the x2 that is represented in the first row, and that one has a coefficient of 1. Then when we go to the second row, or the second equation, we have only x3. All other x values are missing. So it means that we only be filling the column 3 with the coefficient of the x3, and that is 1. So this is going to be 0, 0, 1, 0. Let's go to the third equation, or the third, which will give us the third row. That one, the only x value that is present is the x4. So we only represent the coefficient of the x4 in column 3, and that is 1. So column 4, sorry, and that is 1. So we are going to have 0, 0, 0, then 1. Then, as for the fourth equation, which will give us the fourth row, we have all the components, x1, x2, x3, and x4. So, and the coefficient are minus 6 minus cos t. So minus 6 minus cos t, and then minus 5 and 2. Minus 5 and then 2. So this will be our first matrix here. And this matrix will multiply our new variables. These are the x1, x2, x3, and then x4. Good. You can observe that we did not add the e to just our matrix, because that is a forcing function in the original equation. So we would like to create a separate matrix for it, and that to be a column matrix. So plus 0, 0, 0 e exponent t, because the e exponent t is only represented, or can only be seen, in the last equation. It is absent in the first 3 equations. Good. So this becomes the matrix form of our system of equation. We can simply write it as x is equal to s derivative is equal to, then we'll copy our matrix here, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, minus 6, minus cos t, minus 5 and 2, multiplying x, then plus 0, 0, 0, e exponent t. Then we write the initial value conditions as a matrix. So we'll have 2, neg 1, 0, and 3. 2, neg 1, 0, and 3. So this will imply our x of 0 is equal to 2, neg 1, 0, and 3. So this is the initial condition for this, our system of equation. Thank you very much for watching.